Question 2 of the additional material. Question 2 of the additional material. Additional material. Page 19. Question 2, page 19. Ajanta Digital Solution ADS is a renowned name for manufacturing a wide variety of digital stationery product for office and academic use. Abacus division of ADS is engaged in the production of basic calculators capable of academic and commercial use. It is manufacturing three models, C100, C125 and C500. These calculators are sold to customers through widespread retailers and distributors. During basic background, I'm not seeing anything as of now which is going to help me in solving the question. During manufacturing process, each calculator needs to pass through various steps before it gets ready. PCIe is the essential step and performed manually, where processing chip is being installed, activated and tested. So there's a process called PCIe. Production capacity of Abacus is constrained by PCIe. Basic information, selling price, material cost, labor cost. It will become critical whether it's marginal costing or TOC approach, because answers can change here. Answers will change, not change, can change. Answers are likely to change because we have two approaches. Marginal costing and TOC. We'll see what the company wants. As of now, I've understood that production capacity is constrained by PCIe. All the process and division at ADS are operating for a single shift of 8 hours in a day. Conversion cost per hour including labor cost is 5600. Standard output during a day is either 800 units of C100 or 560 units of C125 or 320 units of C500. ADS is capable of sale more than what they are presently capable to produce in all range of model. Attended a science fair where a robot developed by Synergy capable to assemble. On a random day, if 480 units, 140 units and 120 units of C100, 125 and C500 are produced and sold, calculate at what efficiency level is it operational, interpret the same, compute profit earned. Find production of which model is more beneficial considering the ranking based upon throughput performance ratio. Great. So TOC is what they want us to do. Apply Goldratt's 5 steps to remove the bottleneck at Abacus. This 5 steps was there in one of the problem in just in time. I said I'll not do it now, I'll do it later. So we are going to see it now. Go through this now. Okay, second part of the question is on ranking. Considering the ranking, I would ideally go ahead and do an allocation, find production of which model is more beneficial considering the ranking. So second part is on the statement of ranking. First part, they are saying what is the current capacity utilization. Now listen, you can produce 800 units in 480 minutes. 800 units in 480 minutes, 800 units of C100 or 560 units of C125 or 320 units of C500. You can end up producing any of them. Either 800 units or 560 or 320 or a combination. You go ahead and do a combination kind of a thing also. On a random day, they got 480, 140 and 120. They want to know what is the capacity utilization. Did you utilize 100%, 120%, 140%, 160%, 80%, 60%? What percentage did you use? Working note 1, computation of current efficiency level. Computation of current efficiency level. Current efficiency level, product units, hours per unit or minutes per unit, total standard minutes. Of the 480 minutes, what is the utilization? It could be 480, 460, 500. It can be higher also, it can be lower also. Let's see what is the effective utilization. Product units, minutes per unit, total standard minutes. We have three products, C100, C125 and C500. Three products. Utilization is 480. This is what we have ended up doing. Now they want us to know what is the utilization. 480, 140 and 200. Now listen, product C100, 800 units can be made in 480 minutes. So 480 by 800, 480 minutes by 800, 480 minutes by 800 by 560. To avoid rounding of issues, I'll increase the number of decimals, else there could be a lot of rounding off problem. 480 by 560 minutes and 480 by 320 minutes. 320 units. 480 minutes by 800 units, 0.6 minute per unit. 480 minutes by 560 units and 480 minutes by 320 units. This is the utilization. Effectively, you have utilized so much time. Let me know if there's a doubt here. What the question has said is, you have 480 minutes, you can do 800 or 560 or 320. One of the three can be done in a day. They have done in a combination. They have took 480 from this. If you have produced 480 minutes, you have effectively used 288 minutes. If you produce 140 units, you have effectively used 120 minutes. If you produce 120 units, you have effectively used 180 minutes. So effectively I have utilized so much time, which is more than time available in a single day. So I am currently operating at a capacity utilization of more than 100%, or it could be that my workers are highly efficient. Either workers are highly efficient, current efficiency percentage. It could be two things, either it's workers efficiency or machines efficiency, or I'm doing overworking kind of a scenario. Could be anything. 122.5. 100% is the capacity available. I am utilizing it at 122%. I'm utilizing it at 122%. Utilization is at 122%. Any doubts on this? Do part 2 and calculate to the second part and calculate TA ratio. Calculate TA ratio and then do the ranking. Okay, please calculate TA ratio and then do the ranking. Calculate TA ratio and then do the ranking, because based upon throughput performance ratio they're very clear in the bracket. Even without a TA ratio you can find it, but I would want you to calculate a TA ratio and then do the ranking. You can get contribution per hour. Operating cost per hour is 5,600. Contribution per hour is something you can get. Do a statement of ranking. The statement of ranking can vary if I go following marginal costing format. Can vary, I'm not sure on that, but can vary also. They have not asked for an allocation and all. I'll do the calculation at a per day level. You can do per hour, per minute. I'm doing at a per day level. There's no logic why per day. The only reason I've done per day is the data is readily available for a day, so that's why I'm doing per day. You can do anything. Per minute, per hour, doesn't really matter. Your contribution per unit is selling price minus material cost. Units produced per day is given in the question, not what is random day data. That's not what you need to take into consideration. In a day you can produce 800, 560 or 320. So this is contribution per day. And your operating cost per day is 5600 into 8. This will be my priority order. Do let me know if there are doubts. Again repeating, I have not taken any new concept. If there's a new concept, we'll update the tracker as well. Let me know if there are doubts here. Anyone still doing this? Okay. Now, the theory of bottleneck has 5 steps to remove the bottleneck. The first step is find out which is the bottleneck, which is very clear. The bottleneck is PCIe process. First step is identify the bottleneck, which is PCIe. Second step is ensure full utilization of bottleneck. Ensure full utilization of bottleneck, which in fact is at 122% now. I'm not only fully utilizing, I'm expanding to a great extent, and it's 122%. Ensure full utilization of bottleneck, we are at 122.5%. Third part, all non-bottleneck activities should be subordinate to the bottleneck activity. There could be some other process which is needed in the manufacturing of a calculator. There could be some other process. Don't expand anything other than PCIe as of now. Don't try to do anything with other processes, because even if you save time there, you cannot increase the overall sales. All your non-bottleneck activity, I'm not sure what are the non-bottleneck activity, because I'm not very sure on the technical process, but I'm saying anything it could be, or even your labor process, any process which is non-bottleneck activity, please don't do anything. Step 4, try to exploit the bottleneck activity and increase its efficiency. So what we have already at 122, but we'll have to do something with this PCIe so that you can increase the sales and production capability. So either you do something like a Kaizen costing, you do some value analysis, you do some approaches by which you try to enhance the utilization level of PCIe. That's one approach. Or you go ahead and expand the capacity there. Such that PCIe becomes a non-bottleneck activity. You'll have to do something so that PCIe will become a non-bottleneck. But moment PCIe becomes a non-bottleneck, something else will become a bottleneck. Moment PCIe becomes a non-bottleneck activity, something else is going to become a bottleneck activity, which says step 5 says please repeat 1 to 4 again. Because this is an endless situation. There's no end to it. You'll have to keep analyzing it, because something or the other will be a bottleneck. You will find something or the other being a bottleneck activity. Identification of bottleneck, current utilization, exploit the bottleneck. Non-bottleneck activities are subordinate. Elevate the bottleneck, can be done through business reengineering, Kaizen costing, value analysis. Repeat the process. Is because you will see something else becoming a bottleneck. Identify the bottleneck, which we have identified. Exploit the bottleneck, we are at 122.5%. Non-bottleneck activity are subordinate. Don't try to enhance the efficiency of other activities, because it's not going to help. elevate the bottleneck is either you enhance the capacity or improve the efficiency, do minor changes, do major changes, do something so that it becomes. There will always be one bottleneck in the system. If such bottleneck, then a new constraint emerges as a bottleneck. Hence this process continuous. Ultimately improvement is a never ending continuous process. You'll have to keep repeating this. Any doubts on this?